Hello everybody and welcome to the Valeri Analytics channel. I am Michael Valeri and today's class is all about grouping data and joining it. So in the last class we covered how do you filter data? How do you aggregate data? Today's class is going to be concerned with how do we aggregate data and then disaggregate it using the group by function or keyword. And then at the end, we're going to cover how do we join two tables of data together to answer a single question. So those are the two themes of today's class. And to get started, let's open up class number 3, group by and joins. So we're going to double click on that. I'm just going to copy this and paste it into my Mode Analytics terminal. All of the SQL resources are down in the links below. You're going to want to navigate to the YouTube SQL Immersive curriculum Google Drive link, and then make sure you make an account on Mode Analytics if you haven't already. So let's get started here with the group by. I have a little presentation. So just aggregating data on its own isn't entirely meaningful. Think about this example. If we were just to sum the total number of plays on the albums table that we've been working with, we would just get the number 9,075. And furthermore, if we were to put that into a pie chart, for example, well, we would just get the number 9,075, not broken out by any dimensions or characteristics. The entire pie would just represent the total number of plays. I imagine the next question from this manager is going to be, well, where did those 9,075 plays come from? Could you break those 9,075 plays down by the artist? Could you break them down by the genre? In fact, could you break them down by any columns that are in that data set? So what the group by clause does conceptually is it takes a quantitative number of data and it disaggregates it into specific groups. Let me illustrate this here with one of my favorite examples, the rocks in the box exercise. So I'm going to open up the SQL Immersive guide, slicing aggregates by dimensions. Before we learn the group by, we need to know two things. What is an aggregate and what is a dimension? If we do not have that rock solid foundation of understanding what those two concepts are, we're going to be very lost when learning the group by keyword. Let's start here with just describing what an aggregate is. And in front of us, we have a box full of rocks. These rocks are big. Some are medium, some are small, some are striped, some aren't striped, but there is 6 rocks in this box. The number of rocks in the box, or the count of the rocks, is known as an aggregate. An aggregate is a quantitative number. Aggregates, quantitative numbers. Dimensions. So what are the dimensions of the box? We know what an aggregate is. What is a dimension? What types of rocks are in the box? Well, it looks like there's different sizes of rocks. So big, medium, and small. That's one dimension. What other dimensions are there? Well, whether the rock is striped or not. Could be a yes or no. That sounds like a Boolean column to me, doesn't it? And the weight of the rocks is another dimension, right? You got these 100-gram ones, these 50-gram ones, and then 25. So dimensions, what are they? They are usually qualitative characteristics. In this case, the weight can be used to describe the size of the rock, however. Usually they're qualitative. They're text or string, but sometimes you'll see them defined quantitatively as well. So let's just take a look here and create a table of what this rock output might look like in a SQL query as a SQL output. So we're going to do rock count by size. The count of the rocks we're going to identify as the quantitative column. The count of the rock is, excuse me, not quantitative, it's an aggregate. An aggregate is a number. The size of the rock is what we call the dimension, the characteristic. So, how many big rocks are in this box? 2. How many medium rocks? 2. How many small rocks? 2. At the end of the day, you still have 6 rocks. But in this case, they're grouped by size. They're grouped by their size. Each row is a unique size. Let's look at the rock count by stripes. Rock count is what we call the aggregate, the count of the rocks. By stripe, whether they're striped or not, that's our dimension. That's our qualitative characteristic. So how many striped rocks are in this box? 1, 2. How many unstriped? 4. There are still 6 rocks in the box, but we are grouping them by stripes, where each row is whether they're striped or not, is the granularity. Let's go on down to this third example. I'm going to zoom out. Rock count by stripes and size. So in this case, rock count is our aggregate. The stripes are our dimension. And the size is a dimension. So in this example, we're choosing to group by not 1 dimension, but 2 dimensions. So how many big rocks are there that are striped? Looks like 1. Big rocks that are unstriped, 1. Medium, 1. 1, 2. There's still 6 rocks. You'll notice that as we added more dimensions to our grouping, the result output got more detailed and larger. There's a little note here that the more dimensions or the more things you group by, the more detailed your result output is going to be. You could imagine at some point you could just group by rock ID and you'd see 6 rows of data. Can you see how powerful the group by could be here? For example, you have 6 rocks, but you're able to convert it to just 3 rows of data to summarize it. Or for stripes, just 2, or slicing by stripes and size, we're able to reduce it to 5 rows. So aggregates, dimensions, aggregates, quantitative pieces of information. This is going to be components like sum, min, max, count, count distinct. Those are going to be our aggregates. We learned about them, and their dimensions are what we're going to disaggregate those numbers by, those dimensions. So the exercise says this to learn the group by. It says, hey, can you write an SQL statement that counts the number of rocks by size and stripe? Essentially, can you make this table here? A list of rock sizes, their stripes, and the count of the rocks. Let's try it. Let's do it. What I'm going to do here is open up Snipping Tool, and I'm going to take a picture because we're going to be moving on to the concept of blueprinting or architecting a query from scratch. So we know we have to make this result output. This is our blueprint. This is what the final building should look like. You don't just build buildings by putting code together. First, you want to draw what the building should look like at the end, and then you build it. It's very similar in SQL. So let's hop into Mode Analytics. I'm going to bring up this again. It's really hard to get all on the screen. So it says, write a SQL statement that counts the number of rocks by size and stripe using mValary 12 rocks in the box. Well, what do we know? What does every SQL query need? Select and from. So let's write select and from. In what table we're talking to? mValary 12 dot rocks in the box. In fact, I'm just going to query this table and we're just going to take a look at what it looks like. Here's the rocks in the box table. It gives us a list of rocks. What's the granularity of this table? Every row is a unique rock ID. We get the size of the rock, we get the weight of the rock, and whether it's striped or not. The level of detail of this table is that every row is a unique rock. And our goal is to make this the count of the rocks by whether they're striped and their rock size or not. So, below this query, we're going to begin architecting or building the shell of our code. That's how I like to call it. What columns do we know that we want to see in our resolve output? Well, one of them is count of rocks. So in our select statement, we're going to write count of rocks. We're not really concerned how it's calculated yet, but we do know that it's going to be in our resolve output. This is what we call building the shell. So I'm going to write count of rocks. That's going to be a column that we're going to want to see. We're going to want to see whether that rock is striped or not. So let's write is striped. And then what other column do we want to see in our result output? The size of the rock, rock size. And I'm just going to open up that table in our schema here on the right-hand side. Rocks in the box. Okay, so let's write rock size. Okay, we don't know how these columns are made yet. That's okay. Let me ask you this, though. Let's define whether these columns are aggregates or dimensions. The count of the rocks. Does that sound like an aggregate or a dimension to you folks? To me, that sounds like a quantitative piece of data. It's an aggregate. So we're going to write ag next to it to label it. Is striped. Does that sound like a dimension or an aggregate to you folks? Sounds like a qualitative piece of information, whether something's striped or not. I'm going to say a dimension. Dim. The rock size. Is that a dimension or an aggregate? The size of the rock, whether it's big, medium, or small, is qualitative. It's a dimension. So count of rocks. Now we've labeled which columns of ours are dimensions and aggregates. But how do you count the number of rocks in this table? Well, since every row is a unique rock, if you count rock ID as the count of rocks, that will give you the total number of rocks. Excellent. So what we have here is the 3 columns of data. We've got our aggregate, and we're mixing it with 2 dimensions that we want to understand it by. So I'm going to highlight this code and hit Run Selected. And it doesn't like it. It says there's an error. Something's wrong with the query. It says column rocks in the box is striped must appear in the group by clause or be used in an aggregate function. I'm going to let you folks in on a little secret about the group by and when to use it and why it matters and what you put in it. Number 1, the reason this isn't working is because we don't have a group by clause. So when you mix aggregates and dimensions in the select statement, you need a group by. Because you're trying to aggregate something and then disaggregate it into specific dimensions. You're trying to group it into specific dimensions. So whenever you create a select statement with an aggregate and dimension in it, look, there's an aggregate and dimension, you need a group by. That's why we go through the process of labeling the columns and building the shell. Step 2, you only put dimensions in the group by. You'll never put an aggregate in the group by. You can only group on dimensions, not the number that you're counting. So down here in the group by, I'm going to put the group by under from. Group by comes after from. And cool little note, you can use aliases in the group by. Why can you use aliases in the group by? It's because the order of operations of SQL. Let's look up here. The group by runs after select. So if you create a column here in the select statement, you can use it in the group by. So in our group by, we're going to write is striped. That's a dimension. Excellent. comma, rock size. When I was first learning the group by, you know what somebody told me? They said, the group by looks exactly like the select statement. You just copy and paste all the columns from the select statement into the group by, and then that'll work. And I would run my code and it would never work, and I never understood how the group by actually worked because nobody told me that only dimensions go in the group by. You'll never put aggregates in the group by. So just all our dimension columns from the select statement go into the group by because that's what we want to disaggregate on. Let me highlight it and hit run selected. There you have it, folks. Rock size, big, big, medium, medium, small, whether they're striped, and the count of the rocks. Here's a fun little thing that you can do. Order by comes after the group by. You can start using more than one key. You can start using, wow, look at this, 4 keywords we're using in this query. We could order by, let's say we want all the big rocks together and the small rocks, and then we want to do it by is striped or not. You can actually order by more than one column. Let's take a look at this result output. Ooh, isn't that nice and clean? Big ones first, medium, and small. So the order by is just changing the order of the records. This is a really cool query. What we did is that we reverse architected the code by looking at the result output that we wanted to see. This is so powerful. If you can look at a table of data and reverse engineer it into SQL code, you are learning a lot. So be proud. I would be proud. I am proud. I'm proud of you for tuning in and watching this. All right, let's take a look at the next question here, now that we know how the group by works. So in review, when you mix aggregates and dimensions in the select statement, you need a group by. You only put dimensions in the group by function, never an aggregate, and you can use aliases in the group by because of the order of operations of SQL. Let's look at this next question. Write a SQL statement that counts the number of artists and sums total number of plays by release year using the mvaleri12.albums table. That sounds familiar. Oh, that's right. That's right, because this was the question that we were asked in class number 1. Total plays and total albums by album release year. It's all coming back. It's all coming back. Let me just take a photo of this. We're going to make the data that constructed this chart, or the table. So I'm going to go back to mode, and I'm going to see if I can say, hey, drag this over here just a little bit. Drag this over here. Everyone, thanks for your patience as we just kind of figure this out. I know there's a lot going on the screen. So it says, write a SQL statement that counts the number of artists and sums the total number of plays by release you're using mvaleri12.albums. You could do this on your own right now and then see if you get the same answer that I do. It might be a good test. Here's how I would approach this. Step 1, you're going to build the shell of the code. Step 2, you're going to identify what is an ag and what is a dimension. And then step 3, well, you're going to determine if you need a group by. Step 4 is you're going to run the code. Always start with building the shell of the code first, which is, what do I want my result output to look like? What do we know? Every SQL query starts with select and from. You always start there. That gives you the momentum that you need to be confident. mvaleri12.albums. Let's take a look at this. I'm going to paste that into my from statement. That's the table I'm talking to. In fact, I'm actually going to bring it up here in the schema so I can look at it on the far right-hand side. mvaleri12.albums. Okay, so it says it wants to see total number of plays and total albums by album release year. What is one of the columns that we want to see in our result output? Total plays. What does that sound like to you? It sounds like an aggregate to me. It's a number. Next column that we want to see, the total albums. What does that sound like to you folks? Does that sound like an aggregate or a dimension? Total albums to me sounds like an aggregate. It's a number. The album release year is another column that we want to see. What does that sound like to you folks? Does that sound like an aggregate or a dimension to you? Well, it sounds like a number in this case, but it's actually describing something. It's the year. It's the year. So this is a great example where a number can be a dimension because it's describing the year. So we're going to write dim next to it. So we've got aggregates and dimensions from the mvaleri12.albums table. Okay. Is there anything else that we need to consider here in terms of keywords? Well, folks, what happens when you mix aggregates and dimensions? You need a group by. So we're going to write group by down here. What are we grouping by? The dimensions only. And there's only one dimension in this case, and that is album release year. So we know we're going to be grouping on that. We're trying to look at total plays and total albums and disaggregate it based on the year that the album was released. So I'm going to highlight it and run it. Quite naturally, it doesn't work. Why doesn't it work? Because it says total plays doesn't exist. Oh, goodness. Okay, so that's not going to work. Ooh, it's because all we did was build the shell. We haven't built the ingredients that create the table yet. So how do you create the total plays column? Well, in the albums table, there is a column called plays. So what I want to do is I want to sum the plays column as total plays. I want to sum all the numbers in the plays column. What about total albums? Well, how do I get the unique number of albums in a table? I can count. In fact, I can count distinct on the row or the album name. I'm actually going to choose row though, because row is the primary key. So if I count distinct on the row column, what is that going to do? It's going to count the unique number of album IDs in that column. Now let's try to run it and see what happens. There's a problem with the query. It says album release year does not exist. What do you mean album release year doesn't exist? We have release date, but we don't know the album release year. Why is that? We need to truncate the date into a year instead. What function did we learn last class? To-car. Let's to-car this column. Let's say, hey, can you look at the release date as a YYYY, which is the release year, and call that album release year. Now let's try to run it. You'll notice here that I can use an alias in the group by because group by runs after select the order of operations of SQL. Okay, let's see if these numbers align with the data that I'm seeing in my chart. Ooh. I'm only seeing 2008 though data to 2012, and this result output is 2011 to 2012. I need to get rid of some rows of data here, particularly the ones that are not 2008 to 2012. How am I going to do that? Well, I could say, hey, can you get rid of those rows for me? That's the where clause. The where clause removes rows. So let's remove the rows that are not 2008 to 2012. So let's say where the album release year, remember between single quote 2008 and single quote 2012, why do we wrap them in single quotes? Because they're dates. Dates and strings get wrapped in single quotes when we're filtering data. Data types matter. Let's try to run this again. Looks like something went wrong. Column album release year doesn't exist. What are you talking about? I made it in the select statement. Album release year is right here. Some of you might be remembering, you cannot put aliases in the where clause. Why is that? I'll tell you why again. The order of operations of SQL, where runs after from and then select runs. Where runs before the select statement, so you cannot reference aliases in the where clause. Oh, what a bummer. But what's a way to get around that? You take the entire function itself and you just paste over that alias with the whole function instead. That is a great way to get around it. Now let's try it. Now let's see if those numbers match. Sorry, your query wasn't successful. We ran into problems, but we're going to try it again. All right, album release year, 2008. Do we have 1,400 plays? Indeed we do. Do we have 2 albums? Yes, we do. 2009, 2, 1060, looks good. 5340, looks good. Now we know what happened in 2010. There was no albums released in 2010. So that's the answer to that mystery. 2012, total albums, 1, 300. We did it. This is really powerful. Do you realize how cool this is? We looked at a chart. We looked at a chart of data, not even a table, a chart, and we reverse engineered the SQL code from it. So whenever you're working with a business partner, have them draw the chart on the screen for you. Like, I want you to build me something in SQL. You say, well, hey, tell me what you want to measure. And in fact, can you draw it as a chart for me first? Because then you can identify the aggregates and the dimensions. Then you can reverse engineer that query. You can get the blueprint. You're never just going to want to write SQL from scratch without having that blueprint, either a picture of the table you're creating or a chart to look at. That will help you write the code, I promise you. It'd be like if someone was building a building without a blueprint. A bunch of construction workers came to a construction site and started putting beams up next to each other and go, well, gosh, I hope it makes a building. They don't even know what they're building. So they need a blueprint. You need a chart or a table to reverse engineer your SQL code from. It's just like a word problem. Hope I hammered that home enough for people. All right, let's not save that. So I'm going to reopen this, scroll down, and check out what's next. Something you might want to do is write a SQL statement that slices the following metrics by album genre using the MValeri 12 albums table. Try that on your own. Try that on your own. Paste your answers here in the comments section to see what you've actually done and share it with everyone else. This one's tricky because I actually include some other functions that you can use. The same rules are going to apply, though. You're going to want to identify what the aggregates and dimensions are, whether you use a group by, and then construct the columns afterwards. That'll get you your answer. All right, there is group by homework, so make sure to jump into that at the end of this class. We're going to talk about joining tables now. Another one of my favorite subjects, joining tables. I'm going to pop into the PowerPoint, and we'll talk about even why you join tables and conceptually what it means. I don't like to just start talking about joining tables without conceptualizing what a joining of a table does. All right. I used to teach this in person. That's why it says lunch in an hour. So what is a join? Let me ask you folks this question. We have 2 tables of data. On the left-hand side, we have an orders table with a list of order IDs and customer IDs. In the orders table, every row is an order ID. Table B is every row is a customer ID. If I was to ask you, can you give me a list of orders by customer name? Could you do that? A list of orders by customer name? You could. However, you would need more than one table, which is where joins come in. If you have a question that you can't answer from a single table and it lives in 2 different tables, then you need to use a join. What is a join? In the world of Excel, you may have encountered this. It's where you take 2 tables of data and you smash them horizontally into each other based off some shared ID or identifier. So you create a super table, a table of A and B together, if you could join them together to produce one that had order ID, customer ID, and customer name in it. You'd have this like mega table. In Excel, we call joining tables a VLOOKUP. So if you've done a VLOOKUP in Excel, it's the same concept as a join. You need 2 tables of data that share one column in common, And there's a special note in SQL, which is the column and common must be the same data type. Data types coming back. I'm always going to bring data types back. So what's required to join two tables of data together? You need at least two tables with at least one column or field in common. So generally, it's the primary key joining to the foreign key of another table. I don't like to talk about primary and foreign keys right away, though. I just want conceptually to understand. You get to get two tables to talk to each other, they got to share a column in common, and it's customer ID in this case. And it must be the same data type. The column or field in the second table should be unique, otherwise duplication will occur. We'll talk about duplication in another class. But first, let's just talk about, I'm going to call these easy joins just to make us feel a little better about jumping into joins, because they can be very confusing. We're going to skip the join syntax. So when we're joining two tables of data together, the best way to understand it is to look at it as a Venn diagram. You've got table A and table B on the right. Table A is our center of the universe. It's generally a transaction table. It's the table that's the most important to the business. It's the table that the business couldn't live without. And the orders table, in this case, is probably the most important table to the business. Every row is a unique order ID. A business probably wants to know its total orders more than they do their customer names. So your primary table, the left-hand table, is always on the left-hand side. Now, table B is always your right-hand table in the Venn diagram. In this case, it's the customers table. So think of table A, primary table, transaction table, center of the universe, the sun. Table B, or your other tables, rotate around table A, like planets. And I call them window dressing. They're nice to know information, but not business critical. So that's table A and table B. Now, how do we visualize this concept of an inner join? If we were to smash table A and B together, which customer IDs would you expect to see in the result output? An inner join means only the customer IDs the two tables have in common. So let's take a look. Why is null, let me go back here. Why is null in 8 not in the result output? Well, it's because null and 8 are only in table A, the orders table. They don't have a match. Why isn't customer ID 4 and 3 in the result output? Well, it's because they're only in table B. When you're doing an inner join, you're only looking at the overlap of a Venn diagram. The records that exist in both tables. So customer ID 1 and 2. How many total orders do we have, though, if we look at a result output? Looks like there's 2, but in reality, in the orders table, there's really 4 orders. We excluded 2 because they don't have a match in the customers table. So keep that in mind. Under an inner join, we say there's only 2 orders. Now, there's different types of joins. There's this concept of a left join, which is show me everything in table A, regardless if it's in table B or not. So which customer IDs are we going to see in this result output? Left join. Show me everything in the left-hand table, table A, regardless if it's in table B or not. When we do a left join, we're going to see all the records from table A, regardless if they have a match or not in table B. So we see the null customer ID. We see the 8 customer ID. We see the 1 customer ID. We see the 2 customer ID. How come we don't see 4 and 3? Because those ones only exist in table B. So left-hand join. How many total orders do we have under a left-hand join in the result set? 4. An inner join says there's 2 orders, and a left join says there's 4. Joins will produce different results. I'll give you an example of when I learned this. When I was working as an analyst, surprise, surprise, at Amazon, I was working on Kindle content, and my manager said, hey, can you give me a list of orders by book genre? The book orders table is a primary table, the list of the book orders, and table B is the genre of the book. Well, I decided to join these 2 tables together under an inner join. And I came up to my boss and I said, hey, we've got 20,000 Kindle orders, and they're broken down by these categories: fiction, nonfiction, memoir, biography, science fiction, romance, etc. And he said, there's not 20,000 orders. There's like more like 100,000 that we should be seeing. Why are we missing 80,000? And I said, well, I did a left join. Or excuse me, I did an inner join. I inner joined the orders table to the customers table, or to the book category table. Well, lo and behold, what did I find out? That the book table, table B, the nice to have table, didn't have all of the book IDs in it. Some book IDs were missing. So what ended up happening is if a book was in the orders table, but it wasn't in the book catalog table, it would eliminate the order under an inner join. It would say that that order never existed. It would say it never existed. So when I was doing an inner join, I was excluding things if they weren't part of the nice to have table. Well, if it's nice to have, I probably still want to include it. What's the takeaway here? If you're deciding between a left and an inner join, and you're joining to nice to have information, the left join is the way to go, in my opinion. Now, there are use cases where you don't want to use an inner join, or excuse me, you don't want to use a left join because you only want to find the matches. But if you're joining to nice to have information, you still want to include those orders in table A. For example here, customer ID null and 8. We still include those orders under a left join, but their customer name is null. So instead of just eliminating the order, we show the customer name as null. So we have 4 orders still. To me, that still retains the integrity of the orders table. So in fact, there are many different joins that you can do in the world of SQL. In fact, there's 1, 2, 3, 4, 5, 6, 7 different joins based on the various ways that you shade the Venn diagram. And we're going to go over what they all mean and how they're used in SQL. And then we'll talk about actually how to write a join. So let's hop out here. I'm going to go back into the Teacher SQL Immersive Guide. And we're going to go down to the join section and just conceptualize what these joins mean. This is our joins workshop. I'm just going to zoom in. So you're going to match each join to each business case. And you can do this on your own before we start. What we have here is we have 2 tables. We have an orders table, table A on the left, and then table B is a customers table. Every row in the orders table is an order ID, and every row in the customers table is a customer ID. In the customers table, we have the customer's name, whether they own a dog or not, their email, their phone number. Just nice to have information about the customers. There is 7 different business cases in which you would use one join over the other. And I'm going to walk through what each business case is and when you would use the join and what the name of the join is called. So let me zoom out here and hopefully we can see the whole screen. So let's start with A. If we only want customers who sign up for the marketing list and have made an order. Okay, so 2 things need to be true. The customer must have made an order. They must be in table A, and they must be in the customer marketing list. What does that sound like to you? That sounds like they must be in both tables of data. They must be in table A and B both. So that is option 2 here. Option 2, that's what we call the inner join. They must be in both tables of data. Let's look at question B. If we want to see all customers, regardless if they made an order or not. All customers. Well, it'd be nice to see a list of customers who made an order and a list of customers who haven't made an order that are in the customers table, and a list of customers who have done both things as well. So they're in table A and in table B. Or excuse me. They are part of table A, but they could also only be in A, and they could only be in B. and they can also be in both. So we want to holistically look at the entire customer population. That is number 6, and that's what we call the full outer join. Nice. Let's look at C. Full outer join says show me everything in both tables. C says only customers who haven't completed both actions. So we want a list of customers who have only done one or the other. They've either made an order or they're in the customer marketing list table. They have to have done just only one of those things, but we don't want the ones that have done both. So if they haven't completed both actions and only one action, it's number 7. That's what we call the full outer exception join. The full outer exception join. We're going to talk about exception joins next class, not this class. Number D, only customers who have signed up for the marketing list and have not made an order. So we want customers that are in the marketing list table, table B, but they have not made an order. They're not in table A. So they're only in table B. Who's that? That's number 5. That's what we call the right exception join. The right exception join. Show me everyone that's in the right table except the matches. That's where exception comes from. So when you see the word exception, that means exclude the matches between the two tables. So the right exception join. Only the people in table B. Let's look at E. Only customers who have made an order and not signed up for the marketing list. Only customers who have made an order but not signed up for the marketing list. So they've made an order, but they're not in table B. So they're only in table A, but they're not in table B. So if they're only in A, it's 4. And what do you think that's called? The left exception join. Show me everyone that's in the left table except the matches. Again, exception means exclude the matches. Number 4, only folks who have made an order but are not in the customer marketing list table. I hope this is starting to make sense because you see how these things are inverted. All customers who have made an order. All customers who have made an order. Okay, so show me a list of all customers who have made an order. It doesn't say anything about whether they're in the customer marketing list table or not. So that's option 1. That's what we just call the left join. The left join, you'll notice, includes just the left-hand table and the matches, but it's just still the left table, table A. All customers who sign up for the customer marketing list, that is 2. The right join, number 2. My bad, it's number 3. Number 3. So now we know what all the use cases are for joins. There's a bonus question here. It says, what would be useful for figuring out which customers to promote products to? Well, think of it this way. When you want to find customers who have never bought anything, but they're in your customer marketing list table, I would say number 5 would be really useful. If you want to find a list of people who you want to market products to, it's like, hey, these could be all net new shoppers because they don't have an order yet. So I would say number 5. I think you could make cases for the other ones as well, but I think 5 would be the best for getting a list of customers to market to. So that is conceptually how joins work. Now that we know what a join is, you're getting 2 tables of data to communicate with each other, and then you're either looking for the matches between them, only things that are in A, only things that are in B, etc. Now we can begin the syntax of a join. Let's hop into the mode report, joining tables. We've got 3 questions here, and you guys have been so good today tuning in. So let's go through these. It says use mvaleri12.orders and mvaleri12.customers for these questions. Question 1 says, I want to see a list of order IDs, their order value, and customer name and customer location. What do we know about SQL? Well, the first thing I like to do is just write select and from. That's what matters. Select and from. So I put select and from down. And this question asks me that it wants to know what tables of data I'm talking to. Well, let me ask you this. What do you think is more important to the business, the orders table or the customers table? I'm going to say the orders table. So in my from statement, I'm going to write the primary table, table A first. Primary table, table A. We're talking to the orders table. And then, what's the other table we're talking to? The from clause says the tables that we want to pull from. Now we have more than one table of data that we're pulling from. So we're going to put another table in there. mvaleri12.customers. This is our secondary table. Table B. When you're writing SQL, the first table you list is always your primary table. It's always a table on the left. And your secondary table is table B. It's always on the right-hand side in those Venn diagram examples. So it says, I want to see a list of order IDs, their order value, customer name, and customer location. They must have an order. Well, let's just pop these tables open. Let's just do select star from mvaleri12.orders and see what the ingredients that we can work with are in this table. So I'm going to open the orders table. And then I'm going to open the schema on the far hand right as well. Okay. So here we go. It says I want to see a list of order IDs. So in my select statement, I think I could probably grab the order ID column, and I'm going to ask myself, does this come from table A or table B? The order ID. That comes from the orders table. So I'm just going to make a little note to myself. Order ID comes from the orders table. Comma, since we've got more than one column, what else do we want to see? Their order value. Order value is a column. And where does that come from? The orders table or the customers table? That sounds to me like it's coming from the orders table. Customer name. Is customer name in the orders table or customer location? Doesn't look like it to me. So let's take a look at mvaleri12.customers. I'm going to open up the schema here on the right for mvaleri12.customers. Bada bing, bada boom. All right. And it says, I want to see the customer name. What column of data do you think that is to get their customer name? Remember, we're smashing table A and B into each other. I'm going to say name is the column, and what table does that come from? It comes from the customers table. And it says it wants to see the customer's location. What's their location? Well, location comes from the customers table as well. Okay, nice. We have these columns of data. The fact, though, that we have two tables in our from clause means that we need to alias our tables. So after all of our table names, we're going to write as. The reason we have to do this is because if we smash more than one table together, SQL's not going to know the column that pertains to what table. So we're going to alias the orders table as table A, and we're going to alias the customers table as table B. Now that I've aliased these tables, I'm going to go back to the select statement and ask myself, does the order ID column come from the orders table or the customers table? And indeed, it comes from the orders table. So in front of order ID, I'm going to write A dot. I'm going to alias the column with the table that it comes from. Order value. Does that come from the orders table or the customers table? Comes from the orders table, so I'm going to do A dot in front of order value. Name. Does that come from the orders table or the customers table? Comes from table B, the customers table, so I'm going to write B dot. Location. Does that come from the customers table or the orders table? Comes from the customers table, so I'm going to write B dot. All right, we've aliased our columns, excellent, with the table that they come from. Now we need to indicate what kind of join do we need to use to get these tables to talk to each other. The caveat says they must have an order. The customer must have an order. So it sounds like they must have an order and be in the customers table at the same time. Oh, no, excuse me. They must have an order. I said that wrong. They only need to be in table A. So if something only needs to be in A, the left-hand table, what kind of join is that? They only need to be in A, the left-hand table, regardless if they're in B or not. That's what we call a left join. So in front of that table B, we're going to write left join. Take table A and table B, left join them together, show me everything in table A regardless if it's in B or not. After we left join, we have to specify the column that the two tables have in common. So we're going to write on. What column do these two tables have in common? What can they be joined on? They can be joined on the fact that the customers table has a column called customer ID, and the orders table has a column called customer ID as well. Here we go, cust ID. All right, so in table A, it's called cust ID. And we want cust ID to be equal to what? Table B's column, the customers table, which is called the customer ID. And I'll just bring that table up here on the right. Column's called customer ID. You may have noticed, Michael, the column names aren't the same, but they contain the same information. That's right. You might have a database architect in your life that calls the columns two different things in two different tables. And one table is called cust ID, and the other one that it's called customer ID, which can be really confusing. So sometimes the column names aren't exactly the same, which is kind of a bummer, but something to be aware of. Okay, so I've indicated the aliases in front of the columns, and now I'm going to run the code. It says operator does not exist, double precision equals text. Oh my gosh, you guys remember this error? Does not exist? Double precision text? Something about adding casts? Oh, jeez. What in the Sam Ellington's going on here? It wants us to do something with a cast? What do two tables need to be joined together? 1, a column in common, and 2, they must be the same data type. This error is indicating to us that one of these columns, data types, does not match the other, so it does not want to be joined. Ooh, what did we learn? You want to use the cast function to convert data types. So let's ask ourselves, in table A, cust ID is what kind of column? I'm going to make a note here. And then I'm going to make a note for myself down here in table B. It's always good to look at these data types. This is the stuff that'll trip you up when you're doing joins and go, man, why isn't this working? Customer ID in table B, the customers table, is a string. Here's the schema. String. What is it in table A? It's a float. So one's a number and one's a string. Man, you know what we should do? We should cast cust ID as a string here. If we make cust ID a string, then it can talk to the B customer ID. Type error string doesn't exist. Okay, do you want it to be a text? Don't do me dirty like this. Man, that's such a bummer when it does those things. I think there's an issue in mode analytics where it like shows something as a string data type, and in reality it's a text, and something's a float, and in reality it's like a numeric instead. Man, that's a bummer. That makes things really confusing, and I'm sorry about that. What I'm doing instead is that I'm casting cust ID as a text, just to make it work. Trying to get this to work. There we go. So what do we get? We get a list of all the orders in table A, and then why don't we have these customers' names? Well, it's because they're not in table B. We've got customer ID, customer IDs that aren't in the orders table, or excuse me, the customers table, and therefore we don't see it. There's another way that this could be done, if you're curious, where I could join on a.custID equals b.customer ID, and I could actually cast customer ID as a float. That should give me the same result output. Mode's doing that error thing again. There we go. So you get the same result output. So it doesn't matter which side of the coin you're manipulating, they just have to be the same. Let's look at this next question. It says, I want to see total order value and total orders by location. Excuse me. Well, what do we know about every SQL query? We need select and from. What tables are we talking to? Well, let's actually make the shell of the query first. It says total order value and total orders by location. So we know one of the columns that we're going to want to see is total order value. Right? And does that, the total order value, does that sound like an aggregate or a dimension to you folks? Sounds like an aggregate to me. Total orders is another column that we want to see. Does that sound like an aggregate or a dimension to you folks? Sounds like an aggregate. It's quantitative. It's the total number of orders. The location of the customer. Does that sound like an aggregate or a dimension to you folks? That sounds like a dimension to me. When you mix aggregates with dimensions, what do you need? You need a group by. What goes in the group by? The dimensions only, just the location. So only the dimensions. So we built the shell of the query. Now let's build the ingredients that make up those columns. Let's find what the ingredients are. So I'm going to talk to the orders table first and see, is there anything that we can use in there that could help us make these columns? So total order value, how would we get that? By summing the order value column. So I'm going to sum order value as total order value. The total orders, how would I get the total orders? Well, each row in this data set represents an order. So if I was to count the order ID column, that would give me the total orders. Count order ID as total orders. The location, can I get location from the orders table? Unfortunately, no. What table is that going to come from? It's going to come from the customers table. So I'm going to be using two tables here. This is really cool. I'm writing code that includes, are going to include a group by, excuse me, and a join at the same time. Just taking some time to load here. While that's loading, I'm just going to open up the customer schema on the right because I think I know what the column's called, and it's called location. So order value, total order value, what table does that come from? It comes from the orders table. Total orders, what table does that come from? Comes from the orders table. Location, what table does that come from? It comes from the customers table. So this is interesting. I've got aggregates and dimensions, and I've got two different tables all going on at the same time. But the rules remain the same. I create the shell. I just want to see total order value and total orders by location, those three columns of data. What table does it come from? Table A, the primary table, and Valeri 12 dot orders. Okay. And you know what I'm going to do? I'm going to left join it. I'm going to say show me all the orders regardless if there's a customer ID in table B or not. So I'm going to choose the left join. And I'm going to say, hey, can you talk to mvaleri12.customers and call that table B and call the orders table table A. And I'll make a note here. This is our primary table, left-hand side. This is table B. It's our nice to have table. So I'm going to write secondary table, right-hand side. Nice. What column do these two tables have in common? Well, we already learned that. We're going to use this on command here. You join on the column the two tables have in common. Join on the column the two tables have in common. Make sure it's the same data type as well. Let's try this. I'm going to highlight this and hit run selected. Wow, things are moving really, really slow right now, which is a huge bummer. But I can promise you that this code will execute. I promise you that. So folks, what does this mean? Well, that's the end of today's class. We talked about joins. If I could review joins really quickly, there's a couple steps. 1, build the shell. Identify AGGs and dimensions and tables columns come from. 2, choose a join condition. Do you need everything in table A? Only the things in B? The things that match in both? Ask yourself those questions. Use the Venn diagram to guide you. Number 3 is after you build shell, choose what ingredients make up the columns that you're creating. And then all the rules are going to apply. If you mix aggregates with dimensions, you need a group by. If you're using more than 2 tables, you need a join. That is the group by and joins class, folks. Thank you for tuning in. The homework can be found in the YouTube SQL Immersive curriculum folder. I'll open it up here. And you can start doing the practice questions. Next class, we're going to be doing exception joins and a little SQL review of all the content that we've covered so far. That's class 3, group by and joins. Folks, I hope you have a great day. Thanks for tuning in. Goodbye.